Oh my gosh, 1-12, 1.12. We got one left after this one, and then review, and then it's time for a big old test. Woohoo! All right, not yet. Right now, Mr. Key is here to help ye. Ha Man, I should have been a poet. By the way, all of this stuff can be found at www.NK, stands for Newman Krause. That's my partner in crime, Miss Vicky Newman. Krause Infinity. If you haven't heard my joke before, it's because we like to give an infinite amount of homework.com. Oh my goodness, that's so funny. Anyway, all the videos can be found there in a nice organized fashion for all of you educators out there. They'll give you some links on how you can get some of this material so you don't have to recreate it for yourself. For you students out there, I hope I help you out. I hope I'm providing you with some good information. Alrighty. By the way, if you haven't taken the time to subscribe, hit that subscribe button right down over there somewhere. I'm not sure where it is. You can hit the like button. That's the thumbs up. Don't hit the thumbs down. That's for the other videos, not this one. This one's going to be a big thumbs up. Linear regression. So let's see here. Linear regression. I forgot. This one we have to take a look at this warm-up. This warm-up I think you're going to do in class. Well, all right, let's just do it. Let's see if I can do this. I'm not sure how maybe I'll do it in the Word document. Boop. So if you go to this website, I guess it's from berkeley.edu, and what do they ask us to do? Go change n to 10. Okay, we'll change n to 10. All right, so that gives us some points. And then unclick SD line and graph average. Unclick SD line and graph of average. Okay. Click regression line. There's our linear regression line. Use the sliders to change the value of R and record your observations. So right now R is 0.50. Points are a little bit odd or outside themselves or away. But what does it say? Use the slider. So let's slide 0.62. Wait, hold on. That 0.5 was off. So here's 0.5. Here's really what 0.5 is. Well, let's go to 0. Oh, no, let's go to 0. Let's see what 0 looks like. 0 is like right here in the middle. So 0 points like all over the place, like way up here, way down there. Well, that's crazy. And then if we keep sliding, notice what's happening to the green line as we slide to the right and we get closer and closer to 0.4, 0.5, 0.6. I'm not there yet. There's 0.7. What's happening to the line? There's 0.9, 0.91. 1.0. Notice 1.0, they're all on the line. 0.95, look how close they are to the line. 0.65, kind of far away from the line. 0.88, kind of close to the line. But notice this line has a positive slope. Now, as I get closer and closer to 0, it gets all over the place. The line slope gets closer and closer to 0. It's basically useless. But now just notice what's happening to that line. It's going the other direction now. Now it's coming down. But as I get closer and closer and closer to 1 or -1 out here, look what happens to the points. The points are getting closer and closer to the line until I get all the way down here at -1. At -1, they're all on the line, and the line's coming down. I can't do down. I don't even know which I think it's this way on the video. But anyway, and we keep going this way and this way. Okay, so as we get closer to 1, the points get closer to the line. As we get closer to -1, the points get closer to the line. As we get close to 0.5, they start getting all over the place. Look at that. Point is almost 0. This is almost 0, and the points are like, if you had to draw a line, why did they draw this line? I don't know. They just drew a line. It makes no sense. So anyway, that's pretty cool stuff. So we talked about our observations. I'm not going to record them. We're going to have kids do that in class. When I have the kids do that in class, I'll have them record that. But So what happens to the points when they get close? What happens to the points as r gets to close to 0.1? Oh, wait, hold on. I got to get back into OneNote. So what happens to the points as r gets closer and closer to 1? The points get, I'm going to go over here, closer and closer to the line of best fit, or the regression line of best fit, or the regression line. Yeah, it almost, and when you get to 1, it makes a straight line. With a positive slope. What happens to the regression line what happens to the regression line as r gets closer and closer to 1? Well, the slope increases, I guess. The slope increases. But most importantly, it becomes a stronger model for the points, or the data points in the graph. The closer you are to 1, the regression line, or the line of best fit of the regression line, becomes a better model of the points that were actually graphed. What happens to the r value as it gets closer and closer to, what happens to the points as r? They go all over the place. The points become all spread out. And what happens to the regression line as r gets closer and closer to 0? It becomes a horizontal line. And the horizontal line slope is 0. What happens to the points as r gets closer and closer to -1? Points get closer to the line. To eventually make a straight line. And in this case, the slope decreases. Or becomes negative. It's called a negative correlation. But, you know, when you get to -1, you have a negative correlation. That means as one thing goes up, the other thing's coming down. But it also becomes a better model and a better fit for the data. So the closer you are to -1 or +1, the better the regression line is to as a model for the data points that you created. So what's your conclusion? The closer the R value is to positive 1 or -1, the better the the closer the R value is to positive. Let me just write it down. I'm trying to paraphrase what I want to say. Let me just write down what I wrote. When R is close to 0, the points are more spread out. Okay, let's just start with that. When R is close to 0, I'm just going to tell you what I wrote. I hate this kind of stuff. I can't wait to get to the problem. When R is close to 0, points are all spread out. When R gets closer and closer to plus or minus, I don't like the way I wrote that, plus or minus, you wonder why I type everything, plus or minus 1, plus or minus 1, the points make a straight line with either a positive or negative slope. With either a positive or negative slope. And I'll talk about that in a second. So when R is greater than 0, it's a positive slope. And when it gets close to 1, the better the model. The more you can trust the model that you've created. And when R is less than 0, it's a negative slope. And again, as you get closer to positive 1 or closer to negative 1, the better the model. This is horrible handwriting. I apologize. What you need to know. If R is close to positive 1, it's a very, very good model for whatever it is you're trying to represent. For example, the taller you are, the bigger your shoe size. You know, that's probably a given model. You know, the more you study, the better your grade. The less you study, the worse your grade. Generally, that's true. Sometimes you can get a high, correlation coefficient. So they compare how strong things compare to each other, how strong things relate to each other. I think you got it. You've been getting this for a long thing. Oh, let's define correlation coefficient. Oh, man. All right, so it measures, and then we get the problem. The strength of the relationship between a set of points. It's denoted by R. And just so you know, R has to be between -1 and +1. And again, the closer it is to 1 or -1, the stronger the relationship is. The closer it is to 0, the weaker it is. The closer it is to 1 or -1, the more you can trust it, the more you have a good model. So let's go through these. What happens if I made R -1? So the points lie near the line with a negative slope. So that would make R equal to -1. So I would have a model that looked very close to like this. In fact, if it was -1, this says lie near the line. So if they lie near the line, if it says near the line, so maybe we're looking at maybe -0.95. Near the line doesn't mean perfect, but -0.95 would say, hey, you've got a pretty strong linear correlation. If I draw that regression or line of best fit in there, those lines are all going to make a very distinct pattern going down, and they're all going to be relatively close to the line. If the points don't lie near the line at all, then you probably have something close to 0, and the points would probably be like all over the place, and your regression line would probably be, who knows. So in this case, the points would be all over the place. You just don't even know. And the points lie near the line, but you have a positive slope. You might have something like positive 0.95 or 0.98 or even 0.1. If it was not 0.1, but if it was 1.0, the line, they would lie perfectly on So if it was 1.0, I should use a different color, purple. But if it was 1.0, they would be like this, perfectly on a line. But if it's 0.95, there might be a couple below, might be a couple above, not quite perfect, but generally in a positive slope. So let's take a look at these. For the scatter plot below, estimate the correlation coefficient. So if I draw that line in, that line has a positive slope. Now it's not perfect, but it's good. So I might say something like 0.9. This one here, there ain't no telling on this one. These points are all over the place. This is going to be close to 0. And this one here, man, that looks a lot like that last one over there. It looks a lot like this one, but it's coming down. So how about negative 0.9? This one here is going up, so it has a positive slope. So we might be, again, 0.9. Now look at this one. Look at the difference between 5 and 2. 2 has points all over the place. 5, if I looked at this, it kind of looks like they're coming down like this. So I would say this maybe has something. Now I can see a general shape coming down. The points are all over the place, but maybe negative 0.5, maybe negative 0.4, something like that. And this one here is definitely negative 1. That's negative 1. I mean, those things are like right on that line, perfect right on that line. So that would be negative 1. All right, I think you got the idea of correlation coefficients. Linear regression. We're trying to find the line of best fit for a set of data. Okay. So we are going to use the TI Inspire to find the equation for the line of best fit. And just so you know, this calculator uses, it somehow minimizes the distance between the points in the line, but you don't really need to know that. Here are the directions on how to use it. I'm going to go through and do a particular problem. I mean, here's how it's done on this calculator, and I'm going to do a bunch of problems, so I'm not going to spend a lot of time going through this particular problem. But from the home screen, you would click on this spreadsheet right here. When you get into that spreadsheet, you're going to type the list in, but you got to call one of the lists X and one of the lists Y. So you actually have to go up there and do that. You'll notice on this one, we called one list X and one list Y. We have the list in here. Here are the listed data points, right? This is the point 150, 260, 480, and 600. You want to get your box up to the top right here, just because it signifies where the thing's going to put your equation. You go into statistics, so then you go into menu, statistics, stat calculations, and then you pick linear regression. Notice there's two of them, right? Use the one that makes sense. You know mx plus b. We're not using this one. We're not going to use it. Don't bother with it. And then all you got to do is say, look, I put my x list and I called it x. My y list, I called it y. And when you pop up, it'll say, hey, there's your equation, mx plus b. What do you know that's missing in your equation? And this is one of the things a lot of kids forget when they're working with linear regression and their equation. What do you think we're forgetting? Yeah, the y equals. It's really y equals mx plus b. So m is the slope, and b is the y-intercept. And you'll notice down here, R is the linear regression correlation, that's the correlation coefficient, excuse me, that's the correlation coefficient. And you'll notice this one is Y, which means it is a perfect correlation, is a perfect match. You know exactly what's going on. Let's do a problem. All right, so I think I have my calculator up. I'm going to be looking down at my numbers. So we're going to get those numbers into a calculator. Freeze this now if you need those numbers. But I'm going to go into my calculator and do those numbers. So I click on this. That gives me my spreadsheet. I'm going to come up here and call this X. I call this Y. Maybe. Call this Y. And then I'm going to come down here and I'm going to type in the numbers. 47, 30, 12, 5, and 41, 58, 59, and 65. Now before I do that, let me look to see what these things even look like graphically. So there's my graph paper, nicely handed to you. 47, 41, 47, 41, right about here. And then we've got 30, 58, 30, 58. And then we've got 12 and 59. And then we've got 5 and 65. So if I'm looking at this line, I'm thinking, wow, that would be like the line of best fit. If I had to draw that line of best fit, and that would be probably what it would look like right there. So it's got a kind of a negative slope. So when I graph this thing, I'm probably going to use have a negative slope. So we want us to write our linear regression model for this. When it says model, what they're really looking for is an equation. So I know it's going to be y equals mx plus b, where I need to know what m is and I need to know what b is. Now when you write them from the calculator, write them unrounded if possible. So we put our thing here. Actually, I don't need that. And I go here, menu, statistics, stat calculations, and then we're going to go into linear regression. It hates me when I use my pen. So menu, statistics, stat calculations, linear regression. Now here, what's your X list? Oh, hey, I called it X. What's your Y list? Oh, hey, I called it Y. Notice how I selected those. And it says, where do you want to save this? We're going to save the equation in F. So boom, 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 there it is. I don't know why I said F3. So there are my M and B, right there, M and B. And by the way, if you can't expand this and you can't see more than, let's say, 3 letters, but you have to write it down unrounded, if you click on it, it shows up down here at the bottom. So 0.505612. 0.505612,722. That's probably enough numbers. And that shows the greater that you used your calculator. And then the B value is 67.63, 18989. 18989. So that should be enough. Now we want to round it to the nearest thousandths place. Thousands. So that's 3 decimals. So these are either going to stay 631 or we got to modify it. It's either going to stay 0.505 or we're going to modify it. So now I can write my equation. Y equals. The Y equals is the thing most kids forget. 0.505. Didn't we decide that was negative? I thought when we looked at our graph, we said that was going to be negative. Did I forget something? I think I must have, because looking at the graph, it looks like it's got a negative correlation, not a positive. So let me go back to this graph here. Oh, look, I missed the negative. That's key. That's important. That negative belongs there. If I forget that, that's a huge difference. So negative 5.05, excuse me, rounded to thousands to 3 decimals, 06, negative 0.506. I was so wrapped up with the fact that I forgot the negative. X plus 67.632. Determine the correlation coefficient to the nearest thousands. So we got to go back over here, and we want not r squared, we want r. And our r value is, notice it's negative as well, negative 0.925. So r is equal to, negative 0.925. 937. So r is equal to negative 0.926. That's our correlation coefficient. All right, now I'm going to take a break because I should have taken one a long time ago. Okay, let's do this again. Let's see what we got here. Where's my mouse? There we go. Oh, look at the cute little baby elephant. All right, so we're gonna graph this elephant. All right, let's graph this baby. So 0, it weighs 159 grams. So like right when it comes out, 159. And at 2, it weighs 154. Now, if you know anything about kids, as soon as they come out, they don't eat right away. They don't do things right away. So they lose a little weight. That's okay. But then eventually 7, it's 162. And at 26, let's pop over to 26. 26 days, we're going to be at 185. Oh, I hate that. And at 35 days, we're at 196. And at 68 days, we're at 229. So clearly this has a positive slope. That is a scatter plot. I just drawn a scatter plot of the data. And clearly if I was to draw on the line of best fit, it would have a positive slope. And it almost makes a straight line. So I'm thinking my correlation coefficient is probably going to be pretty strong. All right, so it wants us to write a linear regression model, and we want us to round to the nearest tenth. So let's get that data in. Now make sure that you close out of this and choose not to save it. And then we'll go back in. Call this X, call this Y, and we'll plug those datas in. 027, 027, 26, 35, and 68. 6 data points. And then we're going 159, 154, 162. That would throw things off. 185. Common mistakes are not putting the y equals and not entering the data incorrectly. So you always want to double check, triple check to make sure you've entered the data incorrectly. All right, we'll get right there. We'll go into menu, statistics, stat calculations, and regression. We called our X line Lex, we called our Y line Y, and we click OK. So click over here. Again, there's our equation, y equals mx plus b. So we're coming down here, we're going to write y equals mx plus b. We need to know what m equals. We need to know what b equals. Write the unrounded answer. It's down here, 1.095, 1.095. It shows the greater that you used your calculator. 4759, 4759. Plenty of digits. B, 155.637, 155.637. 38738. 38738. Plenty. Now we're going to write the regression equation round to the 10th. All right, so the 10th place, remember, is right here. We're going to change to a 1, and that we're going to leave as a 6. So my answer to this one is y equals, please don't forget the y equals 1.1x plus 155.6. What do we think? Is that right? Yay! Wait a second. I used x and y, but what were we using up here? T. Notice T. So when I write my regression model, I shouldn't be really using x. I should probably be using T. And wait a second. Notice what they have up here. w of t. So although I can use y equals, they want us to use w of t. So they want us to write this in function notation. So it's not good enough now to write it y equals. You need to write it in function notation like that. Okay. Determine the correlation coefficient to the nearest tenth. Okay, we'll go down. Remember, we're going to look for the r value. Click on that. See how strong that is? 0.9958. So r equals 0.9958. If I had to round that to the nearest tenth, r would be equal to 1.0. There it is. So approximately how much does the elephant weigh on day 10? So what we're going to do is take day 10 and plug it in for time. So w of 10 is equal to 1.1 times 10 plus 155.6. So go to calculator. 1.1 times 10. Did I really need to do that? No, I could have just put 11. Plus 155.6. Do I really need my calculator to know it's 166.6? I don't. But I probably should have picked a different number because that one's got too many sixes. 166.6. So W of 10 is 166.6. And I might make sure it makes sense. Let's see, 10. 166. Is that about right? Yeah, that makes sense. That kind of makes sense. All right, let me save this one. Okay, man, we got the last one. This cool blue car, and it wants us. Oh, it's a BMW. I should have put a BMW right there. BMW, right? That's my BMW Series 3 car. Ownership. Now, come on, a BMW 3 Series costing $32,750. I don't think so, but whatever. Let's get going. So let's see. At 0, it was $32,750. So that's somewhere up here. And then at 1, it was 26,000. This would be 27,000. So 26,000, somewhere around there. And then at 2 is 24,700 and something, so that's right about there. And at 3, it was 22,981. That's just about 22,981. That's just about 23,000. That's about right in the middle there. And at 4, it was 21,4. So there's 21,4 is probably about there. And at, well, this must be 20,000 then right here. Because at 5, it was 20,025, so that's right about there. So, although this is our t-axis, right there is going to be 20,000, right? So, we got a little break. Probably not the greatest graph, but whatever. You get the idea. Now, why is it that it drops so much at the beginning? You all know when you take a car off a lot, 1 year, it loses like so much of its value. And then it just depreciates on looks like a rather straight line. And this is a pretty good linear correlation. If I ignored that first year, I'd have almost a straight line right here. But, you got this. So, this arguably, at first could look like maybe it's not linear, but you got to argue, you got to get rid of that first year. All right, so let's get going. Let me get this data in our calculator. Pretty simple to do. Keep clicking on the wrong one. All right, so go to menu. Let me get to this. I still have that old one in here. See how I have this one here? It's still old. I want to get rid of it, so I just get out, don't save, and go back in. Call one X, call one Y. And let's type these in. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Boom. And 32,750. Get them in there right, kids. 26,730. 26,730. 24,736. 22,981. 21,421. And 20,025. All right, come up here, we go menu, Stats, stat calculations, linear regression. I called this X, I called this Y, and we click OK. All right, so I've got the information I need. Again, I'm doing y equals mx plus b. I got to tell the grader what m is, and I got to tell my teacher what b is. So let's go to m. Ooh, look at that slope. Negative 2,323. Negative $2,323 and 05714. 05714. Now they're rounding to the nearest dollar here, so I'm not going to go more than that. That's enough. And then go down here, 3581, 3581.47619. 47619. So if I wanted to round to the nearest dollar, that means no decimals. So that means my equation is going to be, now do they want us to use a special thing rather than y and m? V of t and t. So we're going to write this in function notation. So we're going to write v of t. I don't know what that is. That's not even a v. So we're going to do v of t is equal to negative 2323 t plus 30,581. All right, there's my equation. And determine the linear correlation coefficient to the nearest hundredth. Let's see how good this correlation. Pretty good, negative 0.9508. So negative 0.9508 rounded to the nearest hundredths. R is equal to negative 0.95. And that's it, kids. That's all she wrote for linear regression. This should have been a whole bunch of review. Things you got to remember, put the data in correctly. Don't forget the y equals or the function notation v of t or w of t. What I really want you to remember is the stronger correlation is closer to 1 or negative 1. Can't go bigger than that. Can't have a correlation coefficient 1 or negative 1. At 1, it's perfect. At negative 1, it's perfect. Closer to 0, crap data, right? And so the stronger the correlation, the closer it is to 1 or negative 1. If you get all that from today's lesson, you pretty much got what you need from this lesson. All right, kids, hit the subscribe button, hit the like button, leave me a comment or two. Don't tell me how good looking I am. I know, it's the hair. I gussied it up for you today. Goodbye, kids.